Okay, as we start video 2 for the virtual day number 2 in Algebra 2 Honors, problem number 4 is for you to try. So hit pause, give this a shot. It's a lot like number 3. If you get stuck along the way, or you make some progress and get stuck, or you get the whole thing working and want feedback, hit play and get yourself some feedback. You know, one thing I hope that you thought about doing to solve this by factoring is to rewrite it with a 0 on the right side. So I hope that you made some consideration into rewriting it this way, for starters. If 27x cubed equals -1, then 27x cubed plus 1 equals 0. Now, this is, again, of the form where it's not a difference this time, but a sum of two cubes. Because 27x cubed could be written as 3x cubed, and 1 could be written as 1 cubed. So this can be factored as a sum of two cubes. The factorization here would give us 3x plus 1. And let's see, the first thing squared would be 9x squared. Let's see, same, opposite. I need this times this. 3x times 1 is 3x. Same, opposite, always positive. I need this squared. 1 squared is 1. So I'm ready to use the zero product property again. Either this factor equals 0, either 3x plus 1 is 0, or this is 0. 9x squared minus 3x plus 1 is 0. This is simple to solve. It's linear. X equals -1/3 is one of my solutions. But to solve the other two, I need another option this won't factor. I don't even really think I want to use complete the square here, because complete the square doesn't work very nice unless I have just x squared, or can easily get just x squared. So I think I'm going to resort here to the quadratic formula. I think I'm going to say x is the opposite of b, which is +3, plus or minus the square root of, now I need b squared. -3 squared is +9. Minus 4 times a, which is 9, times c, which is 1, all over 2 times a, 2 times 9, which is 18. So I've got 3 plus or minus, 4 times 9 is 36. I've got 9 minus 36. And 9 minus 36 is -27. I've got 3 plus or minus the square root of -27 all over 18. Now the square root of -27 I can simplify, but I need to find the biggest perfect square that goes evenly into 27, and I think that would be 9. And again, since I'd also like to deal with that negative sign, let's make -9 times 3. By 2 factors. The square root of -9 is 3i. So what I have is 3i radical 3. So I get x is 3 plus or minus 3i radical 3 all over 18. Now, I do want to point out that we did say previously, when we were using the quadratic formula to solve, that if the answers could be simplified, well, you should do it. So the thing to do is to look at the coefficients, top and bottom, and those could all be divided by 3. So let's do that. Let's divide them all by 3. So divide this by 3, and this. Don't divide the radical by 3, just the coefficients. So let's do 1 plus or minus I radical 3 all over 6. And there's really my other two answers, aren't they? Because one would be 1 plus I radical 3 over 6. The other would be 1 minus I radical 3 over 6. So there are our 3 answers. All right, number 5. Last example before you try some on your own. We've got 9x to the 5th plus 6x cubed minus 8x equals 0. I see that I can factor out an x. Nothing more. There's no number other than 1 that goes evenly into 6, 8, and 9. So I could factor out an x to leave 9x to the 4th plus 6x squared minus 8 equals 0. You know, I see this as of that factorable form of x to the 4th x squared and a constant term. I wonder if I can make it work. Let's see if we can factor that. Let's try setting up a box to factor. If this trinomial is going to factor, 9x to the 4th needs to fit here. Negative 8 needs to go here. I need to find something x squared and something x squared, but I don't know what the somethings are. It could be 1 and 9. It could be 3 and 3. And similarly, I've got options for the 8 as well. It could be 1 and 8, or it could be 2 and 4. So I need to find the pair that would make positive 6 here in the middle, the pairs plural, I suppose. Let me try putting 3s, and if this doesn't work, we'll go back and try something else. And let me just try the 2 and the 4. We'll put the 2 here. I guess it wouldn't matter, 2 and 4, since they're both going to hit 3s. You know, I think I might have lucked into the correct one on the first chance. 3x squared times 2 would be 6x squared. 3x squared times 4 would be 12x squared. And since I need the signs to be different and get a positive 6, let's do negative here and positive here. And sure enough, those do add up to 6x squared. I think we've got it. I think we've got our factors. So I've got x times 3x squared plus 4 times 3x squared minus 2. And I think we're ready to use the zero product property. So either x equals 0, boom, that one's done, or 3x squared plus 4 equals 0, or 3x squared minus 2 equals 0. So I've got one answer already dealt with. These two I could probably solve both by using the square root property. To solve this guy here, 3x squared plus 4 equals 0, I could say that 3x squared equals negative 4. And I really could say that means that x squared equals negative 4/3. Now I want to think about what to do now because I need to use the square root property. What would the square root of negative 4/3 be? You know, the square root of a fraction is the same as the square root of the numerator over the square root of the denominator. And I could say that I know the square root of negative 4 is 2i. I could do 2i over radical 3. That's not the worst answer out there. So let's say that x is either 2i over radical 3, or it's the opposite of that square root, negative 2i all over radical 3. We can do something similar here for 3x squared minus 2 equals 0. That means that 3x squared equals 2, or that x squared is 2/3. Now, the square root of 2/3 really doesn't simplify. We could simply say x is the square root of 2/3. Or we could say x is the opposite of the square root of 2/3. And there are our 1, 2, 3, 4, 5 solutions. What's left for you to do here is that you've got some practice on your own. If you struggle or if you're stuck somewhere, work together, help one another out. Also shoot me an email. My email is open. If you are struggling, come see me later this week during homeroom periods if you need to, and we'll get this one done, Panthers. Thanks for watching.